OK, so now that we know we're using UDP, let's dig in and see what a DNS packet actually looks like. How do you take that stuff in English, like what is the IP address of eeks.berkeley.edu, and how do you put that into actual code and encode it in ones and zeros? So because this is a UDP packet, we first need to build a UDP header. Remember when we talked about wrapping headers around each other and moving down the stack? Well, first we have to build this layer 4 header. So here are all the things you need in the layer 4 header. You need a source port, which says what room number or application on your computer is asking this question. So your computer can choose any source port number you want. It can be whatever number you want. It's like numbering your bedroom or your bathroom. It doesn't matter. The reply will just come back to the same port. And as long as you know that, that's fine. The destination port is like the room number in public. That one has to be fixed and well-known. And it's a well-known fact for all computers that DNS is on port 53. So if you want to ask a DNS server a question, you always ask them on port 53. They leave that port open for connections, and they don't listen on any other port numbers. So we pick 53 for the destination room number or port. That's who you talk to. And then there's a checksum just to make sure the stuff isn't corrupted inside the UDP payload. And then there's a length, which tells us how many bytes are here. And that's the entire UDP header. So this is the layer 4 header. Everything in here is in gray from the perspective of UDP is the layer 4 payload. UDP isn't thinking about what's inside its packet. And it just sends this packet along. So if we actually do open up the UDP packet, we can see what's going on at layer 7. So remember, the outer header is layer 4. The inner header is layer 7. So here we're opening up layer 7's header to see what's inside. So there's 3 main header fields that we care about. One is the ID number, and that helps us associate queries with responses. So imagine if your computer sent out multiple DNS requests, and you got multiple answers back. How do you know which request corresponds to which answer? You set an ID number, and the name server replies to you using the same ID number. That's how you know that a particular request matches a particular response. So if you send 5 packets with ID numbers 10 and 30 and 500, then when you get the packets back and you get back responses, you can look at their ID numbers to figure out which one corresponded to which question. You can also randomize this for security. That's something we'll see later when we discuss attacks. Then there's a bunch of flags, which we won't even talk about. They're not that interesting. And then there's a bunch of counts. What are we counting? We're counting this stuff inside the DNS payload. So let's talk about what's in here. And these headers are just telling us how many records exist. So that's the layer 7 header. Now we can open up the layer 7 payload. This is where you actually put your DNS questions and answers. So everything up here was just metadata to help us send the packet. And here, we finally get the DNS payload that encodes our questions and answers. So DNS encodes everything in records. And a record is a name-value pair. So think of a Python dictionary or a map in Java. Every record is a name-value pair. You have a name, you have a value, and you can put records in one of 4 sections. So it's like 4 boxes where you can put your records in. And where you put the record depends on what it's being used for. So there's a section for your questions. So if you're only asking a question, put something in the question section and leave the other sections blank. If you have an answer, you can put it in the answer section. And if you don't know the answer, but you want to redirect to someone else who can help, you can encode that using these 2 sections down here. So everything's stored in terms of records, and that's going to be useful for caching, as we'll see later. Every time you get a record, you can cache it. So this is how DNS organizes its data by using name-value pairs.